corrosion and basics of powder. Corrosion is a natural process that converts a refined metal to a more chemically stable form. Now, what is this chemically stable form that we will discuss, such as oxides, hydroxides, sulfides, etc. It is a gradual destruction of materials, usually metals, by chemical and or electrochemical reaction with their environment. In short and simple language, we get the metals from ores or minerals. Now, this particular form of these metals, these are oxides or some kind of salts. Now, these metal salts, as ores or minerals, is the stable form. So they are there in this form for years together, and naturally there is no further degradation of those ores. Now, what we do is we take out these ores. We are putting a lot of energy onto it, and this energy, heat or whatever, we are converting that to pure metals. But they do not have a tendency to stay there. They have a tendency to go back to their original form, which is a stable form, which is ore. So oxides or sulfides, nitrides, hydroxides, whatever. And this process of going back is usually we are calling it as corrosion. Losses due to corrosion, you can see these pictures. These are not the only material loss. It could be a structural strength loss or other losses. And some studies have estimated that as much as 4 to 6% of GDP of the country we are losing because of metal corrosions. Normally, as we come to automobiles or any other even appliances like refrigerators, washing machines, etc., their main corrosion is a cosmetic corrosion. Cosmetic corrosion starts on the exterior surface of the automobile or a lot of other things also, in railways also, or etc. Due to localized damage of the paint film, paint or powder coating film. Whenever we are talking about paint film or powder coating film, the meaning remains same. The bare metal is exposed to the environment. This affects the aesthetics of visual exterior painted surface due to red rust and stains that are lateral spreading of paint film resulting undercutting. That is what we call as creepage. Creepage means the corrosion or rust moving between the paint film and the bottom material. That is what we call as substrate. So you can see here, this is the end result, but it has started, maybe there are some cuts here, and the corrosion has started going in. And because of which we are getting this bubbles, we call them as blisters. Below this, most of the metal is corroded. So likewise it goes. That is what we call as creepage. Creepage word you will always be familiar with in case of salt spray results. Perforation corrosions. Perforation corrosions, this will lead to serious structural damages. Remains undetected until it becomes visible on the exterior surface. Normally what happens is this perforation, what you have seen here, has started from inside. For a lot of time or most of the time, maybe the paint film was quite intact, but the metal was rusted. Strength had gone, and one fine day, that paint film also cracked along with the remaining metal parts, corroded metal parts. This can happen because of road debris, plugging of drain holes, inadequate cleaning of phosphating, or primer coating in interior surfaces of body. Due to design constraint, there's something called as throw power in CED. CED is cathodic electrodepositions. So poor throw power of CED. General rules of corrosions: when metal is in contact with its immediate atmosphere, moist air is more corrosive than dry air. Hot air is more corrosive than cold air. Hot water is more corrosive than cold water. Polluted air is more corrosive than clean air. Acids are more corrosive than bases or alkalis. Salt water is more corrosive than fresh water. So these are general rules of corrosion. Now, how we can control the corrosion? Ways of controlling the corrosion. We can protect our assets by use of more corrosion-resistant materials, which is not always possible because probably you make a car in stainless steel or something. They have already started making some expensive cars in aluminum, but that is, I think, not from the corrosion point of view. That is from the strength and weight point of view. It reduces a lot of weight. That is why they've gone for aluminum cars. But you make cars out of corrosion-resistant material like stainless steel, which will be impossible to do. Modifying design and procedures, not always possible. To a certain extent, yes, you can do that. Modifying the environment is utterly impossible. You cannot do that. Using protective coating like paints, powder coatings, electroplatings, etc. So this is the easiest way out of all this, is coating. Put a coating on that. Now, when we are putting a coating on that, that doesn't stop the corrosion. Okay, it will only delay the reaction, delay the corrosion reaction. Now, in this, powder coating is a simple process of applying a thin uniform cured coating which protects the metal surface from environmental attacks. Now, marine, I have specifically shown one picture on the right, GIF on the right. This kind of salt water goes into the ships. This is, of course, a smaller ship, not a big ship. Big ships don't do this. Sorry. So you must be knowing what kind of controls or what kind of corrosion can happen there. What is paint and coating? Now, liquid paint is a material in liquid form which, when applied, dries to form a film which imparts protection and decoration to a product. Now, powder is already in a dry form. So we apply and cure it in the oven to create a similar film like what we are getting with paint, dry paint film. On the component, you can see those photographs. There are a variety of industries who are using powder coating. It could be automobiles, architectural, valves, your cupboards, refrigerators, etc., washing machines, automobile industry, engineering industry, you can say control panels like Kalpesh was speaking about. So all these are now powder coated. The powder coating evolved some 50 years back, rather evolved in 1950s, but came to actually industry usage by 1970s, 75, something like that. And after that, it has replaced a lot of liquid painting to powder coating, because there are certain advantages of powder coating which we will be discussing. Now, composition of powder, what goes into the powder. Coating powder is a homogeneous material of heterogeneous material. Now you have resins, you have pigments, you have additives. Now these resins are basically the polymers, which we just were talking, like polyester, epoxies, epoxy polyesters, etc. Pigments are the colored powders which we are adding into that, and additives are special, they will add some special property. Now there are two technologies in the coating industry. One is liquid coating technology, which we call as wet technology, It is in existence for more than 2 centuries or maybe more than that. The powder coating technology is just in existence for about 50 odd years. In these two technologies, powder coating application is much simpler than liquid paint application. Now, the advantages, somebody was asking what are the advantages over liquid. One is powder is ready to use. There is no viscosity adjustment, no hardener to be added, etc. etc. The application method is much easier. It's a single coat system. Variety of finishes like texture, structure, these finishes would be available without any additional skills of the coater. Of course, coater will need good skill to do texture or structure finish, because if the DFT varies, the structure finish also varies. So there the skill, but doing similar kind of finishes in liquid you don't get all the finishes, they are not available. But if you want to do these finishes in liquid, naturally there are the coater's skill plays a very important role. Okay. Then there are certain other advantages which are not mentioned in this list. Are powders can be recycled, collected and recycled. So the usage of this powder is almost 95%. Why pre-treatment? It is compulsory to clean the surface from rust and impurities and convert it to better surface condition to achieve the best coating life. This process is called as pre-treatment or PT. Now you can see this is an oil patch here. Then these black patches are again oil plus dust. These are again oil plus dust. If you don't remove this, no powder or no paint will stick onto that and will create a problem. So we will start with powder coating application. Powder coating application again gets divided into 3: cleaning. This is the pre-treatment. Depending on your component, the raw material or MOC, what we say, material of construction, the number of tanks, the difficulty in doing that, all that will decide the number of tanks. After that, it goes to oven. After oven, it is loaded onto the conveyor. And conveyor moves, comes here for coating application, then goes into the oven, and your baked material or cured material is out here. So here somewhere they will be loading after cooling. This is typically a conveyorized powder system. With batch type, these systems will change. Even this automations and movement, material handling, all these things will change with the demand, basically. Volumes and what are their frequency of coating, how many square feet you are coating every day. All these things will decide the type of material handling, automation, material, ease of material handling, all these things. Now the first one I was talking to you about yesterday is fluidized bed coating. Now in this, let's go to this figure. You have a perforated plate here. This is what is called as a plenum chamber. In this, we are pushing the compressed air at about 6 bar. It has to be very clean, dry, without oil, air. And we are putting the powder on this plate. Now with this air push, that powder will start bubbling in this. That is what we call as fluidization. You can see this fluidization. The things which are coming out are bubbles, air bubbles. Now we heat the job, preheat the job to about 150 degrees. Again, depending on the powder, it may vary. And just dip it into that fluidization. So probably this particular rod is hanging one hot job there. So whatever powder particles come in contact with that will get molten and they will stick to it. Then you take it out and put it in oven for curing. That is how this is done. Now, the disadvantages are you don't have any control. There's at the bottom, the amount of powder particles are higher compared to top. So the DFT variations will be there. Job to job temperature variation. Suppose I put one at 155 degrees, second at 150 degrees, third at 145 degrees. The melting and deposition will vary. So job to job variation in DFT also is expected. So basically, need of powder coating testing is pigment coating testing is a critical part of product evaluation. So naturally, you need to do it on a regular basis. There are four different types of tests, what we call as mechanical strength test, which includes scratch hardness, impact, flexibility, hardness, adhesion, and curing degree. So this is mainly what we are doing at application end. Aesthetic appearance test, DFT, gloss, color, hiding, DOI, in which DFT and gloss normally we are checking here and color sometimes, if you are doubtful. Chemical resistance or corrosion resistance, salt spray, humidity, ultraviolet test, concerned chemical resistance test. Now, these appearance tests usually do not damage the coating. So we call it as NDT, non-destructive, and rest these are usually the destructive tests.